guys, welcome back to another episode of BackStreet Blabs.
AP Chem can be a dense course, as we know, so today we wanted to give you guys a little run through on different topics just to help you tackle the unit throughout the year. So today we're going to be talking about VSEPR.
First, let's break it down. So VSEPR stands for valence shell electron repulsion theory, and this is basically about the overall bonds and lone pairs that will be arranged in a way that allows for the least amount of repulsion. Now, the geometry of molecules really depends on the electron domains, such as bonds and lone pairs, which is around the central atom. Now, we will be discussing 5 domains in the VSEPR theory. The number of bonds in the lone pairs tells us the number of domains that the compounds will be in. Okay, and in domain number 2. Okay, in domain 2, there's one structure, which is linear. In linear, there are 2 bonds and 0 lone pairs around the central atom, and this is in a linear 180-degree shape.
Yeah. In domain 3, there are 2 structures. We have trigonoplanar and bent. Trigonoplanar has 3 bonds and 0 lone pairs around the central atom. For bent, you have 2 bonds with 1 lone pair around the central atom. This makes a bond angle of 120 degrees. This is classified as having 3 domains because when you add the number of bonds with lone pairs, it equals up to 3.
Hello. So in domain 4, there are 3 structures: tetrahedral, trigonopyramidal, and another bent shape. Tetrahedral has 0 lone pairs and 4 bonds connected to the central atom with a bond angle of 109.5 degrees. The trigonopyramidal has 1 lone pair and 3 bonds connected to the central atom and a bond angle slightly less than 109.5 degrees. The second bent shape has 2 lone pairs and 2 bonds connected to the central atom with a bond angle of around 104.5 degrees.
In domain 5, we have 4 different structures. You have trigonobipyramidal, seesaw, T-shaped, and linear again. Trigonobipyramidal, which has no lone pairs around the central atom, but has angles of 120 degrees and 90 degrees. Seesaw-shaped structures have 1 lone pair on the central atom with 4 bonded atoms. And T-shaped has 2 lone pairs with 3 bonded atoms. And finally, we have linear, which has 3 lone pairs and 2 bonded atoms at the top and the bottom of the central atom.
In domain 6, there are 3 structures: octahedral, square pyramidal, and square planar. Octahedral has 0 lone pairs and 6 bonds connected to the central atom with a 90-degree bond angle. Square pyramidal has 1 lone pair and 5 bonds, while square planar has 2 lone pairs and 4 bonds connected to the central atoms.
So molecules, no, sorry, I said molecules. Okay. Hello. So molecules composed of any nonpolar bonds are nonpolar regardless of their shape. These are molecules in which the central atom is surrounded symmetrically by identical atoms equidistant in polarity from the central atoms, even if the bonds themselves are polar. These shapes include linear, tetrahedral, trigonobipyramidal, trigonoplanar, square planar, and octahedral. All the other shapes are asymmetrical, and molecules with these shapes contain any polar bonds. Molecules with these shapes that contain any polar bonds are polar as a whole. Well, hopefully you guys were able to learn something new and possibly use this information to give you a jump start in AP Chemistry.